The night sky. Isn't it marvelous? Do you guys ever feel inspired, or lightened up, by gazing at the beautiful night sky, when you were depressed or sad? Does it not make us wonder, that how many scientists and astronomers, have built large telescopes pointing at the sky in search of answers to many questions in the universe? Have you thought about those explorers, who have traveled along the path guided by the night sky to explore the unexplored? About those artists, who are inspired by the beauty of night sky, and invoke the art in them into a masterpiece? How some poets and authors, have written their unique piece of literature about the night sky? And those children, who are curious to know what they are, and have dreamt of visiting this magnificent dark night sky, filled with stars. What are your thoughts on this? Let us know in the comments below. Watch the video until the end to know more about these stars, which may be the source of energy for the life out there, just like our sun is to us. And don't forget to like and share the video, and subscribe to our YouTube channel. So, let's begin the video. Stars. There are more stars in the observable universe than the entire grains of sand on Earth. But what are these stars? How are they formed? So, let's get to know. A star is an astronomical object, which consists of a luminous spheroid of plasma held together by its own gravity. Our sun is a star. And it is the closest one to us. The next nearest star, named Proxima Centauri, is around 4.25 light-years away from Earth. If you want to know how large the observable universe is, and how far away is 1 light-year, then check out our video on the vastness of the universe. Link is in the description and also in the I button at the top. The formation of stars begins in the regions of space, which have higher matter density. These regions, known as molecular clouds, consist mostly of hydrogen, with about 23 to 28% helium and a few percent heavier elements. One example of such a star-forming region is the Orion Nebula. Due to the radiation of massive stars, expanding bubbles in the interstellar medium, or even by the black holes, the molecular clouds are pushed closer. This causes gravitational instability within the molecular clouds. When a region reaches a sufficient density of matter to satisfy the criteria for Jean's instability, it begins to collapse under its own gravitational force. These regions within the molecular cloud are known as Bok globules. As the cloud collapses and density increases, the gravitational energy of the gas falling into the globules is converted into heat, and the temperature increases. When this protostellar cloud reaches a stage known as the hydrostatic equilibrium, where the inward gravitational force is balanced by outward hydrostatic pressure gradient force, a protostar is formed at the core. These pre-main sequence stars are often surrounded by a protoplanetary disk, and powered mainly by the conversion of gravitational energy. The period of gravitational contraction lasts about 10 to 15 million years until the formation of a protostar. These newly formed protostars emit jets of gas along their axis of rotation, which may reduce the angular momentum of the collapsing star and result in small patches of nebulosity known as Herbig-Haro objects. These jets, in combination with radiation from nearby massive stars, may help to drive away the surrounding cloud from which the star was formed. Most of the stars observed were formed in a binary or multi-star systems, in which 2 or more stars are bound gravitationally and move around each other in stable orbits. The properties of these stars depend on the conditions in which they are formed. In general, the molecular clouds are so vast that there are multiple Bok globule formation. In order for a cloud to form a star, it must lose its angular momentum and then collapse under its own gravity. Hence the formation of multiple stars distributes some of that angular momentum. Due to this reason we can see more of binary and multi-star systems. Some of these stars, especially the primordial binary ones, were split apart more widely from each other, because of the gravitational interactions between them and the young stellar clusters, during the close encounters. These stars can have a very different post-main sequence evolution compared to the single, same-mass stars. If stars in a binary system are sufficiently close, and when one of the stars expands to become a red giant, it may overflow its Roche lobe, which is the region around a star where material is gravitationally bound to that star, leading to transfer of material to the other. When the Roche lobe is violated, a variety of phenomena can result, including contact binaries, common envelope binaries, cataclysmic variables, and type 1 of supernova. Stars can form part of a much larger gravitationally bound structure, such as a star cluster or a galaxy. For most of its active life, a star shines due to thermonuclear fusion of hydrogen into helium in its core, releasing energy that traverses the star's interior and then radiates into outer space. This stage is called the main sequence stage of a star. The mass of a star plays a major role in influencing the star's path to attain its eventual fate. If you consider the amount of time a star spends in the main sequence, it depends primarily on the mass of hydrogen gas that is present in a star, and the rate at which a star fuses it. Because of the fact that a star has different properties in its different stages of life, and that the life of a massive star differs from that of a low-mass star. This classification of stars, their properties and evolutionary phases will be discussed in the next video on stars, which will be dropped soon, so make sure that you have subscribed to the channel to receive the notification when the new video is out.